Okay, 1.4, surface area of other composite objects. So before we were dealing with rectangles mostly, right? So that would be something like, well, a rectangle, where that would be base times height. So maybe that was like 3 times 4, right? So the area of that would be 12. Okay, so now other composite objects, we're going to be dealing with triangles and circles and 3D versions too. So in a second with the circles, we're going to have cylinders, right? Two circles and then the side on it, right? So let's, just to get into it here, just get into some questions. So let's go down to this one. This one's going to be very similar to questions we've done in the past already. So the tent has the shape of a square-based pyramid that's shown below, including the base. The surface area of the tent, the nearest hundredth of a square meter is. All right. So what we got to do here, we need to figure out the surface area of one of those triangles, and then, well, how many are there, right? There's 1, 2, backside, 3, and then 4. Okay, so first off, let's just find one triangle. Now, what is the formula for a triangle? Formula for a triangle, area is equal to base times height divided by 2. This is on your formula sheet, you guys, so you don't have to memorize that. Sometimes it's also written as area is equal to 1/2 base times height. Same thing, right? 1/2 times base times height is the same thing as base times height divided by 2. Okay, so that being said, the base, let's say, of this triangle, well, the little tick there means it's the same as this length. It's a square. So this is also 1.6. So let's put that in. So the area is equal to, I'll use the first one. My base is 1.6. My height, so times, my height is 2.4, right? The height is like the height of my face going up here, right? The tallest part of my triangle is my height. It wouldn't be this one, right? That would be the side of my triangle. The height is going to be right from the middle all the way up in this case. All right, so 2.4 divided by 2. So what do we get there? All right, we get area is equal to 1.92, and then remember we're in meters squared, right? So you might say, hey, perfect. Got the right answer. 1.92, 1.92, right? They're trying to trick you. We're not done yet, right? All we did here was we just found one of the faces. Okay, so now what we're going to do, we're going to multiply by 4 to figure out all of the triangles. So we'll take that number and we'll go 1.92 times 4. Okay, so we get the area now is equal to 7.68 meters squared. I'm going to put a box around that. And then again, you might say, hey, perfect, 7.68. Again, we're not done. We need to find the bottom, right? We got to find the bottom of our shape, which is just a square, because it said a tent has a shape, and it says including the base. So we have to include the bottom as well. So that is just going to be 1.6 times 1.6, right? Just length times width to get the area of a square, which is also 1.6 squared, by the way, either one. So 1.6. So we get 2.56 meters squared. All right, then add them together. So you add those together, and we get the area is equal to 10.24 meters squared. Okay, so here that would have been B. All right, next one. So in this one, it says we have 4 identical triangular prisms. So, and they're arranged together to form one large triangular prism as shown below. The 5 exterior surfaces of the large prism are then painted. Okay, so what that means, so it says we've got 5 of these shapes, right? Like that one. And then we put them all together. After we put them together, then the outside of everything is all painted, right? So that's what they're saying there. And then it says to the nearest square meter, what is the total area of the painted surfaces? Okay, well, This should kind of remind you of some of the ones we did in 1.3, right? Where let's figure out the area of each of the faces and then count how many faces there are, right? So this won't be too bad to figure out the area of that one, right? That would just be 20, right? 20 times, and then careful on this one. There's actually, you might not be able to see it that well, but there's like 2 ticks on these guys, and they're all 20. That would mean that every one of these lines is 20. And then there's 1 tick like on all of these ones, which would mean that this is 12. Okay, so the area of that one would just be 20 times 12. So that's going to be 240. All right, so that's every one of those faces. Let's count how many of those faces there are. There's 2 on the front side here, 1, 2, and then 3, 4, and then don't forget the bottom, 5, and then 6. So I'm going to go 6 faces times 240, the number that I found there, right? So we get 1,440. Okay, I'm going to put a box around that because we're going to need that in a second. Now, so we're done all the boxes. The problem here now is the triangles. So let's work on those. We want to figure out now, let's find the area of one of those triangles, and then we'll count the triangles and figure out the total here. The problem we have is the formula for a triangle, for the area of a triangle, is area is equal to base times height divided by 2. I have a base. The base of this one's 12. But what's my height? It's not that obvious, right? Remember from the last question, the height should be this on a triangle. It should be the height straight up and down. Okay? Well, I can actually solve that. The height of that one, well, we can find that if I turn this thing into a right angle triangle by splitting this thing right down the middle. That wasn't very good lining. I'm in trouble here with making a straight line. Okay, it's still not great, but so that's a right angle triangle. Okay, so if I do that, then I can see, well, this little tick here, remember, that meant that this side was 12. It's 12 from there to there. So the hypotenuse of that right triangle I made there is 12. Can you guess what the length from here, from the middle of this to the outside is, from there to there? Well, it's going to be half of this, right? That's going to be 6. All right, so we can start working on this now. We have a right triangle, and we know 2 of the sides, right? We know the hypotenuse and the other one. We can use Pythagorean theorem to find this. So here, I'll write this over here so we've got some room. So this is going to be, well, I have the hypotenuse already, and not this side. I'll call that h. So I'm going to write it as c squared minus b squared is equal to a squared, right? Instead of a squared plus b squared is equal to c squared, because I already have c, right? I have that. So it's going to be, instead of plus, it'll be minus. All right, so let's fill this in. So we've got c squared is 12 squared minus, and then b I'm going to call 6, right? So that'll be 6 squared is equal to, you know, I could call it, here, I'll call that a. So we're speaking the same language here. So we'll call that a squared. Okay, so 12 squared minus 6 squared is 108. So 108 is equal to a squared. Very last thing we're going to do is take the square root of both sides. So those cancel, so we get the square root of 108 is equal to 10.39. So that's equal to a. Right, so that means our height here is 10.39. So we're pretty good to go now, right? So now we can find our area, right? We can find the area of the whole thing. So that's going to be the area of that triangle is going to have a base of, and I'm going to use 12, right? I'm going to use the whole base of the bottom. Okay, so 12 times the height of that, which was what we just found, 10.39 divided by 2. Okay, and now at this moment, here, I'm going to find this and then I'll discuss where you might have thought that I went wrong here. But just one sec. So we're going to go 12 times that last number I found. and then divided by 2. So that gives me 62.35. Okay, so now what you might have thought, where like, I might have just made a mistake here, is you might have been thinking, how come we didn't use 6 for our base instead of 12, right? Well, we could have, but if I would have used 6 for my base, then all I would have found was the area of half of that triangle, right? So you could, yeah, you totally could, and then we'd just have more triangles to add up after. I used 12, and that accounted for that whole triangle now. Hopefully that made sense. So either way, so now every one of those triangles is 62.35. Okay. Now we just need to add them all up. So let's count how many triangles we have. So in the front, we've got 1, 2, 3, 4, and then 4 on the back. So there's 8. So I just got to go 8 times 62.35. So that ends up being 498.83. I probably shouldn't have put a box around that yet. So then what I was saying is that whatever I have in the box, I add those together, right? So then in the end, that'll be all of my rectangles. So that number, centimeters squared, right, for the area, plus 498.83 centimeters squared, plus 1440. So we get 1,938.8 centimeters squared. So 1,000, so it looks like it rounds up to A here. All right, find the surface area of the shape below. Okay, so first off here, let's figure out, I'm gonna make my own little question here too. We have to think about cylinders in general. So if I have a cylinder, that means I have, well, shape like this, right? And, well, how many circles are on my cylinder? I've got 1 circle and 2 circles, right? So if I'm making an equation, let's say, for the surface area of a cylinder, then, well, the area of one circle, the area of a circle is pi r squared, right? Well, how many do I have? I've got 2, right? So first off, if I'm going to figure out just the area of the top of that cylinder and the bottom of that cylinder, then the area is going to be equal to 2 pi r squared, right? When I find my cylinder. Okay, so we found the circle, like figure out the that part of it. Now, what we have to figure out is, but what would the area of the outside of this thing be, right? Like, how could we ever figure out what that is? Well, if you could imagine, if this was like the label of a can, let's say, right? And you peeled the label off, like maybe cut it down here and then just unwrapped it. You can imagine that what you'd end up getting is a big rectangle, right? Like if you wrap the whole thing out, where the height of it is this height, right, up and down. So, you know, that would be, you know, call that height. But then the question is what would the length of my rectangle be? And you can imagine here, if you unwrap this whole thing, that the top of that rectangle was the top, or was really the circumference of my circle, right? It was all the way around. Like I said, if that was like a label, like on a can, and you unwrapped it, then the top of my circle was the distance around there, the circumference of my circle. Okay, so what that means is that if I want to find the next part, that's going to be, you know, plus, and then the circumference of a circle, right? If I find the circumference of that circle, is going to be 2 pi r, right? That's what the circumference of a circle is, right? 2 pi r. Okay, and then times my height, so then times h. And there you go. That is the equation for cylinder. Now, you could write it all out and plug it in every time, right, if you wanted the whole cylinder, but a lot of our questions don't require us to find all the parts of the cylinder. So let's go back here. I'm just gonna, hopefully you left yourself a little room. So now let's do this question. All right. So if I'm looking for this one, what I'm going to do is I'm going to find the area, let's say, of the bottom of this guy first. Okay, so just bear with me. Let's find this one. So the area of that circle would be, so area is equal to, and then remember area for a circle is pi r squared. Okay, so the area is equal to pi, oh, what's r going to be equal to? So r, remember r is half of the diameter. So r is from there to there. So that's going to be 13, right? If the whole thing is 26, then the radius is going to be 13. So that's going to be 13 squared. Okay, so let's just actually plug that in and just get like a decimal for now. So we'll go pi times 13 squared. It's going to be 530.929. I'll just leave a few decimals there. All right, so now what did we find there? So we just found this, right? Now watch this. I'm going to do a little trick here. What if we multiply that by 2? So if I go that times 2, that would find 2 circles, right? Look what we found. Imagine the top of this, right, would be that whole top and all of this. Yeah, can you see it? Like if you can imagine, if you like push that center thing down like into it, then that would be the same as the area on the bottom. That really saved us a lot of time, because now I don't got to find like, you know, the area of that ring or whatever and like subtract the area of the bottom of that one. We can save a bunch of time there. We already found it all just by timesing by 2, or by multiplying by 2. And now if you think about it, all we have left here is just the outsides of these guys. I just got to find that area and I got to find that area. So let's find, okay, so let's find the area of the outside of this guy first. And, well, actually, no, sorry. Let me back up one. Let's rewrite this after we multiply that by 2, just so we don't lose our train of thought. Let's write what that number is. Okay, so that's going to be that times 2 is 1,061 point, let's go 858. Just to keep a few digits, and that was centimeters squared. Okay, I'm going to put a box around that, because we're going to add that up in the end, right? So that's all of our circles that we did there. Okay, so now let's find the area of the green part I'm shading there right now, like the outside of that cylinder. Remembering that if I unwrap that whole thing, right, that was like the label of a can, that would end up giving me a rectangle. The outside, or the up and down part of that rectangle would be 8, right? That really is this side of our of the height there, right? Or this side of our rectangle. Now the top, remember, that's the circumference of this circle. And the circumference of a circle is on your formula sheet, if you can't remember, but it's going to be, the circumference is equal to 2 pi r. Okay? So 2 pi r. So here, let's actually just put it in. We'll go 2 times pi, and then the radius was, remember we said that was 13? Kind of got scribbled out there, but that was 13. Okay, so 2 times pi times 13, or diameter times, I won't get into that. Let's just say 2 times pi times, times 13. And we get 81.681 centimeters. All right, that's this top, right? This was 81.681. All right, so if I want to find the area of that, that's just going to be finding the area of that rectangle. So that number times 8. So we're going to go 81.681 times 8 is equal to 653.45 centimeters squared. All right, I'm going to put a box around that because we're going to add that up in the end. Okay, one more. So now we just got to do the same thing, but with that face, right? So that's just going to be, here I'll draw it in the rectangle so that we We know what we're dealing with here. So the up and down part of this is 5, right? So that's going to be 5 for our height of that one. And then the circumference is going to be 2 times pi times, okay, the radius of this one was, okay, well the diameter was 14, so the radius is 7. Okay, so the radius is 7, so that'd be, so C is equal to 2 times pi times 7. So that would be, the circumference would be 43.982 centimeters. Okay, so that's what the top of my rectangle was. That was 43.982 centimeters. I'll leave the centimeters off for a second. Okay, so if I want to find the area of that, that's going to be that number times 5. So we'll go, okay, well that's 43.982 times 5. Okay, so that times 5 is going to be 219.911 centimeters squared. Put a box around that. Now, like I said, my method is just adding up everything in a box. So we're kind of done, right? We found everything. So the red part accounted for the bottom and that and the top. The green was that, you know, that green part, and the blue was the outside for the blue part. So that's it. We're done. We just need to add them all together. So if you add it up, 1061.858 plus 653.45 plus 219.911, we get, well, what do we get? We got that. All right, that equals 1,935 point, let's say 2 centimeters squared. So really just 1,935 would probably be good, centimeters squared. And then I'll circle my answer. All right. Next one. So it says a half pipe, such as those used by skateboarders, is shown below. Okay, so looking at this half pipe, we can see that it has a diameter, right? Like if this whole thing was a circle going from there to there, if it like went all the way around, then the diameter of that, well, half a circle is 10. The length of it is 20. Okay? Now it says, what is the area of the curved surface of the half pipe to the nearest meter? Okay, so one thing, like you don't need to write this down, but I just want to show you something. If this was, well, better than that, a full cylinder, right? Like if this went all the way around like that, and it was a full cylinder there, right? Well, can you see that we actually wouldn't add the circles on the end? Because the circles on the end are open, right? That's not part of the surface. All we want to do is find the surface area of just this stuff, right? Just this part of it. Okay, well, that means if I was thinking about my cylinder from the last one, right? We don't have to do as much as we think, because I don't even have to find the area of these two circles, right? I don't have to do area is equal to 2 pi r squared, right? 2 circles. Like I don't have to do that part because they're open anyway. All I have to do is figure out the area of, well, this part, which is, well, remember when we opened it all up, right? If we had our cylinder and we opened the whole thing up, do you remember how we were looking at a rectangle? Right? That would be the whole thing. So all we're going to do, we're going to find the area of that rectangle, like once we opened it all up. But then it's a half pipe. I only need half of it, so I'm just going to divide it by 2 when we're done. Okay, so let's do that. Let's find, as like the whole thing here, all the way around. So let's find the circumference of that all the way around, because remember that is like the top part of our rectangle. So the circumference, they've told us, of a circle is pi times d. Okay, I was telling you before that circumference is equal to 2 times pi times r. Well, that really is the same thing, right? Because 2 times r, like if I just take that part of it, 2 times the radius is the diameter, right? So they are the same. So let's just use the one they gave us here. Circumference is equal to 2 times, or sorry, pi times diameter. Okay, so the circumference is equal to pi times, the diameter is 10, so pi times 10. So we're pretty close here. Let's put in a number for that just to get our bearings. So we can go pi times 10, and we get, oh yeah, I should have done that in my head, 31.4159 meters for the circumference there. Okay, and then the height, right? Because so if we think about it, what we just found there was of that rectangle, the circumference is the top. So that's like 31.4159. And then the height of our cylinder, right? The height is 20. So that would be 20. I guess this isn't the scale, but you get the idea here, right? So now if I want to find my area of that, that would just be 31.4 yada yada times, so we'll go here, I'll write it out again, 31.4159 times 20 is equal to 628 point, let's say like 318. I'm just leaving like extra digits there, right? 319, I guess it should have been rounded up. I'm just trying to be more accurate. It doesn't really, like, it's not too bad if we like rounded it to 0.3 or whatever there too. Okay, so that's what we got there. Now remember, that was the whole, we just found like the lateral area, which is like just the outside of it or whatever, of the whole thing. Last thing we got to do, we're going to go 628.319 and just divide that by 2. So divided by 2. So we get 314.159 or 2, which is really just going to be, we'll say 314 meters squared for area. Okay. Last one. Okay, what about shapes with holes in them? All right. So in this guy, what we're going to do, let's start with what we know. I'll get to the whole part when we get to it. Let's actually just figure out the stuff that we know already. Well, first off, I always forget this. Can you guys see that there's a hole in this? So can you see that we're dealing with, you know, a rectangular prism, and then there's like a hole missing out of this thing? It goes like right to the back there. Like with those dotted lines, I mean, it's like inside, right? So if you can't, maybe pause it and see if you can actually see that, because yeah, every year I always notice that kids can't actually like see it in the picture. It's like an illusion or something. But yeah, what we're gonna do, let's figure out the surface area, let's say of this outside face first, okay? So we know how to do that. It's just length times width. So that's gonna be like 8 times, well, whatever this one is. And that's 5, right? Because if that side's 5, then so is that one, and so is that one. So that's 8 times 5. Okay, so 8 times 5. Nope. 8 times 5. And then, which is 40, right? But I'm going to go 8 times 5. And then if there's any repeats on these, I can just multiply it by how many there are. And I can see that this is like 5, and that side's 5 as well, which would make this side, the back side, and the bottom all exactly the same. They're all the same area for each of them, right? So if there's 4 of those, I'm just going to go times 4. Okay, so 40 times 4 is going to be 160. So 160 centimeters squared. I'll put a box around that because we're going to use that in a second. So there, we found the outside. Now let's find the front face and the back face. Okay, so how are we going to find this front face? Well, let's figure out the area of the whole square, right? We'll just do the whole thing at first. And then why don't we subtract the area of the inside square? Okay, because the inside square is missing, right? There's a hole right there, so we can subtract it out. Okay, hopefully that made sense. If not, work with me here, and I think maybe we'll get there. So the area of the whole thing, like this whole square on the outside, would be 5 times 5. Okay, so that's equal to 25. That'd be the whole purple area. Now, we don't want the whole purple area. We need to take that green square and we got to subtract that out, right? We need to take that one out. So I'm going to go, well, that one would be 2 times 2 would give me the area for that one. So that would be 4. Okay? So if I want just the purple area, right? Like just, here, actually I'll do a different color now. Let's go make that red. If I want like just this area, right? Then that's going to be 25 minus 4. Okay, 25 minus 4. So that would be 21 is just the area that I have shaded all the way around the outside there. Okay, perfect. So now, how many are there? Well, there's this side, but then the back side's exactly the same. So let's go 21 times 2. So 42 centimeters squared. I'm going to put a box around that because I'm going to add that up in the end. Okay, now all that's left is the inside, and this might take a second to think about, but once we cut like the center out of this and made a hole through it, then what you've done, you've actually made it so that the inside of this box is also a face that's showing. Like there's a face showing there and the back side and all through, right? Like you could actually touch it. Like if you had like, you could stick your finger in there and you could actually touch that. So that is a new surface that we've introduced. So we need to figure out the surface area of, well, let's say like of this shape on the inside, from like there to there, right? That's a rectangle on the inside. And actually, since this side's 2 and this side's 2, that rectangle would be the same as this rectangle. And that'd be the same as this rectangle. Oop. And that'd be the same as the top, right? All those rectangles would be the same. So all we gotta do is find one and then multiply it by 4. So let's go, okay, the rectangle on the bottom would be, well, 2 by, well, can you see this, that the length from one face to the other, it was 8 from there to there, so it's gonna be 8 here as well. So 2 times 8, okay, which is gonna be 16. And then how many are there? Well, there's 4, so 16 times 4, so 64 centimeters squared. Okay, and then last step, add them all up, right? Add everything in the box. So we're going to say 160 plus 42 plus 64 is equal to 266. And then centimeters squared. And circle your answer.